Well, everyone, thanks for joining for mastering today, whereas we're going to see how to use column formulas to get more out of our data. We have two primary goals for this basic session. One is the how of column formulas, that is, how to build them. And that's in contrast to the what, where we're talking more about specific formulas for specific applications, because there's potentially infinite applications and potentially infinite column formulas. I also hope that you might envision how you can use formulas with your own data. We are going to cover this how of column formulas with respect to a few specific examples, and hopefully these will kind of get your own gears turning about what types of column formulas might be useful to you. So I've said column formulas about 5 times already. What exactly is a column formula? I think actually we should just begin by looking at a few examples. Here I have some data on 2000 and 2010 populations of major metropolitan areas in the US. You'll also see I have this population change variable here. And this is a variable that I've created with a column formula. That is, it's not hard-coded in the data table itself. It's actually being computed by this simple formula here, where we take the 2010 population and we subtract the 2000 population from it. What we're looking at right now is JMP's Formula Editor, and we're going to spend a lot of time in this Formula Editor today learning how it works, how to use it effectively. But first, let's look at a couple additional column formulas. Here I have data on a lipid panel for 95 individuals. So I have their age, height, weight, their cholesterol levels, and so forth. You'll notice for triglycerides, I have their triglyceride levels as well as a categorical variable that categorizes them as nominal or normal, borderline, or high. This is actually specified by another column formula here. So in this case, it's a conditional formula where we look to see if triglycerides fall above, below, or within certain levels, and then assign our labels based on that. And to look at one more and highlight kind of some of the more creative things you can do with column formulas. Here we have some monthly sales data for about 12 years. And in this column, for each row specified, so whether it should be graphed with a regular point or in this case an open diamond. Now the open diamonds are actually flagging months where our year-over-year sales growth was at least 20%. And this, in fact, is being set by a formula where it's determining where we've hit that growth target and then assigning a marker state based on that. So you can actually manipulate things like your data table itself using column formulas. So column formulas, at their core, are useful for creating new variables that then we can use in our analyses and our graphs and so forth. To put it more formally, column formulas are expressions that dynamically compute the values that are stored in all of the rows of a column. They're often based on other columns. I'm trying to overwrite these data right now. And I can't, because all of these rows' values are determined by a formula. So likewise, because I can't change those values in the population change because they're based on the formula, if I change one of the columns on which the formula is based, now we can see that the population change has changed in response. Let's go ahead and undo that. So it's a nice way to have a column, or the values in a column, update based on changes you make to the data table. It's also a nice way to compute values when you add data to your data table. So you can see down here the last row we have is for Tyler, Texas. But we can add some new metropolitan areas to this data table. So here we have the next 163 largest, starting with Las Cruces, New Mexico. So let's just concatenate those in. And when we do, you'll see that even though that new table didn't have population change in it, those values have now been computed. So another benefit of these column formulas, we get all of these new computations. So that's kind of how a column formula works and maybe why we would want to use one. Column formulas themselves are specified as part of a column's properties. So this is, you can think of where the formula lives. When I right-click on a column header, you'll notice that there's a formula option with a little check next to it saying that the formula is specified. Under the full list of column properties, you'll also find formula living right at the top. It's the same thing that we're looking at with the check mark on the left there. It's just so prominent and so useful that we actually pull it out onto the main menu as well. And I can even go to column info, where I can see a list of all of my column properties again, that the formula is specified, and I even see what the formula is and have an option to edit it. Perhaps the quickest way to tell which columns you have are based on formulas are looking over in the columns pane over here. So you'll notice for a few of the columns in my table, we have a little plus sign. That's an indication that this is a formula column. And in fact, if I click on the plus sign, I'll go right into the formula editor, which again, we'll take a look at pretty extensively coming up in just a couple minutes here. But I do want to cover a few other things first. Many of us are used to using spreadsheet software, and spreadsheet software typically allows you to use formulas as well. It often looks like this. So let's say I wanted to subtract something off of the 2010 population. Well, I could double click, and if I know how to specify my column formula, I could start typing it in and say, okay, take the 2010 population and subtract. Well, let's say, actually, let's divide by 1,000. So now we're changing the units. This will be in thousands of people for population. So that's been computed like you would expect if you're used to formulas in spreadsheet software. But you'll notice now if I click on this, what's actually stored in this cell is no longer that formula I typed. So the demonstration for this column, and I hope you saw what we were going through, is that unlike in spreadsheet software where you would simply type in a formula, like I was doing before, in JMP, that formula will evaluate in that cell, and the formula gets thrown away. You're just left with the value. So this is a key difference between how you might be used to typing formulas into something like a spreadsheet and JMP. So you don't type them into the cells. That is, they're not specified at the cell level. They're specified as part of a column property. And that's because every value in a column in JMP needs to be a value of the same variable. So you can't have multiple formulas computing essentially different variables in a single column. It would violate the structure. So the take-home point there is that formulas in JMP live in the column properties and compute across the whole column, so that each column contains a single variable, not multiple formulas specifying different variables. So if that's not how you make a column formula, how do you do it? There are a couple different ways. We've seen glimpses of the formula editor, but I'd like to show you an even simpler way first. So a number of what we'll call standard or very common, very simple formulas are available to be made for you automatically with just the click of your mouse. Let's take a look at 2010 population. So we were talking about how we make column formulas. While we've seen some of the formula editor, there's actually a quick and easy way to create what we would call maybe some standard simple formulas. You can think of them almost as prepackaged, and you just access them point and click with your mouse. If we look at the 2010 population, for example, you'll probably notice it's pretty positively skewed. That is, there are a few metro areas that have a much larger population than anyone else. In that kind of situation, we might want to do, say, a log transformation. It's a very common way of dealing with a problem like this. So instead of going into our formula editor and using that tool, I can actually just right-click, go down to New Formula column, and in some of these submenus here, live the option to request a log transform, for example. There are, in fact, many kind of prepackaged standard formulas that you can apply simply on a right click. So there's a way to get simple formulas that you might want without ever actually having to go to the formula editor. That's actually what I did to get this population change variable. So all I did was highlight both of these columns here, right click, and under New Formula column, I have the option to combine, that is, do something with the data across multiple columns, and just ask for the difference. You can see that now I have values that align with that population change we saw before. Because underlyingly, it specified that exact formula, the 2010 population minus the 2000 population. And what's nice is now, because this has been saved as a regular old formula, I can still edit it. If I'd rather have this be a proportion population increase, I could simply divide this by our 2000 population and click OK. And now this is a proportion population increase instead of the raw population increase. So you can create a lot of these quote-unquote standard formulas simply by right-clicking and selecting New Formula column. And then if you get that and you want to just tweak it, you can always go into the formula editor and make a quick change. So we've already seen the formula editor a fair bit. This is the main tool for creating formulas in JMP, and it helps us create custom formulas to do basically whatever we want. The possibilities are really infinite, and so I'd like to spend some time looking at the formula editor now so that we can understand really what it is and how it works. Let me close our population data and open up a new table. This is a food journal, so we have every item eaten across just about 10 days or so. Here, say the data for December 21st. Each row is one item that was eaten, and we have information on which meal it's from, the name of the item, its category, and so forth. All the way to the right, I have a column that is percent of daily calories, and what this does is it takes the calories for any given item and divides it by the total number of calories consumed that day to determine what percentage calories that item accounted for the day, which is nice because I can create a graph like this, easily track that, oh, well, on December 21st, looks like I was getting my calories from fruit, supplements, and vegetables. The 22nd, I was having fruit as well, but now actually candy and it looks like maybe a mocha are accounting for a bit more. So this is specified by column formula. Let's take a quick look at it. You'll see that it's relatively compact, not particularly complex. So what we'll do now is make this formula. That's piece by piece, and in doing so, we'll explore the various parts of this formula editor interface and see how it works. So I'll create a new column here and bring up the formula editor. So this is the blank formula editor window that you'll see when you begin to create a formula, and it has a number of basic components. In general, you can think of it as a calculator where you specify first in this formula box what calculation you want to perform. So that image in the journal is just for your reference later. It shows what a complete formula inside the formula box looks like. Right now it says no formula in the actual formula editor because we haven't specified anything yet. You can create a formula in this box either via point and click, or if you like, maybe if you know a little JSL, you can always type a formula in. If I double click here, you'll see it pulls up a little text box. So if I knew that I wanted to divide calories by something, I could start typing this in. If I click this little icon to expand it, I actually get a lot more screen real estate where I could keep typing my formula as I like. But we're not going to do a bunch of typing or really look at JSL today, so don't worry about that. I just wanted to show that that's possible for those who might prefer to type their formulas in. So let's look at this point and click interface that we have here. To begin to specify a formula, what we need to do is pull information in from our columns. That's the second main portion of the formula editor, is this column list. So we see our available columns, and if you're used to seeing column lists all over JMP, you might know then that the red triangle gives you specific options for filtering, or that is searching your column list or specifying which types of variables you want to see. We don't have too many columns here, so we don't really need any of that stuff. So I know that I want to take the calorie in a given row and then divide it by the total calories for that day. So I pull calories from my column list, and you can see it was automatically populated into the formula box. So now I need to specify the division, which takes us to the next portion of the formula editor, the keypad, which is this series of buttons up at the top. So the keypad specifies both common mathematical operations, which you'll find on the left side here. So we're talking addition, subtraction, taking a root, things of that nature. And then on the right, we have some common formula editing actions like undoing and redoing, deleting, and so forth. And we'll take a look at some of these. So to specify division, I can simply click the division sign. Or actually, for a lot of these, I can just type on my keyboard as well. So if I undo that action, now I'm just going to hit the slash on my keyboard and bring that division sign in. Let's undo that as well. Well, we'll leave it there. So I've specified the division. The next thing that I need to do is specify the denominator, which is the total calories consumed for an individual day. And this brings us to the fourth main component of the formula editor. That's the function list. So in the function list on the left and depicted there, you can see we have a number of different groupings. So all of the functions that you can perform on your data are contained in these groups. For example, if we look at the numeric functions, you'll see things like rounding a number off or taking the absolute value of a number. You may notice as I hover my mouse on some of these, little tips pop up that tell you a little bit more. So here for the absolute value, it tells us this returns the absolute value of x, and the argument can be a number, a matrix, or a list, and so forth. So what we want to do is find in this list the thing that will calculate the sum total calories for each individual day. So we can put that in the denominator here. So what I'm going to do is use the built-in filter here. Let's just type in sum and see what we get. This returns a few results. Each of these is a different function we can use in our formula. We see something like the sum down here. This returns the sum of the arguments. So that is, I could specify multiple things to feed into the sum function, and it'll add them all up. So really what we want is something that just sums across all the rows. That's the column sum right here, which says returns the sum across rows. So it's nice to use the filter to kind of narrow down the possibilities, which function you're looking for, and then use some of this hover help to determine which one exactly it is that you want to use. And if you're seeing a function and you ever want to kind of know more about it, there are a few things that you can do. If I right-click, I can show it in the scripting index here, which is one of JMP's many help tools under the help menu. And I get the full description here along with some example JSL code below to play with to understand how it works a little better. Finally, I've also included a link in the journal, which we can share with everyone, where if we click on this button, we will be taken to the JMP help page for all of the functions that are possible in these formulas, and you can click on any of these individual categories to learn more about the functions. So let's add this column sum function because I want to take a sum across the calories for a given day. So you can see if I click that, it's added, and now I have the opportunity to tell it what I want the sum of, which is our calories column. So let's see what happens when I apply this formula and actually ask JMP to perform the computations. So we're starting to see now the proportion of calories any given row accounts for across the entire column calories, that is across the whole data set. So not quite what we wanted. We wanted calories, the sum calories calculated on each individual day. You may notice right here we see this little caret after calories in our formula. That tells us that this column sum function can actually take multiple arguments. That is, you can feed it more information than just the column to operate on, which will kind of refine how it does its computations. If I want to actually add that additional argument, I can click this little caret icon up at the top, which, as you can see, just matches the shape of the little icon down below. That's how you can remember what it does. And now I have the option to add a second argument to the function, in this case a by variable, which in JMP by variables just mean do this calculation separately for each group. And I want to group by date. Now when I click apply, you can see those values in column 10 over there changing, and now I have the proportion calories within every given day. So pretty simple formula here. I've taken the calories divided by the sum calories per date, using the formula box, bringing different columns in from my column list, and finding the proper function, in this case call sum, in my function list on the left. Now there's one more thing I'd like to do. If you remember looking at the original formula here, we actually performed a rounding operation as well. And this will highlight another important thing about the formula editor. So let's search for round. Kind of saw it previously in the numeric group. So this is what allows us to round off to a certain number of decimal places. So if I click this right now, and I'd like you to pay attention to the blue highlighting in the box right now where it's around date. That just happens to be where we left off because date was the last thing we added. If I click round, you're going to notice that now round is wrapped around date. That is, we've applied the round function to the date column because that's what was highlighted. So we definitely don't want to do that. We're not rounding date. We want to round the whole thing. And this goes back to something we didn't really mention at first when talking about the formula box, and that's that this blue selection, kind of the little border that you're seeing on different pieces here, highlights the scope of the action we're going to take in our formula. So because date was highlighted, when I click round, round only applied to date. So we don't want that. We want to round the whole thing. Here's a little trick. If you're ever in this situation, you might think, okay, well, how do I get rid of this round? Do I have to delete it and then re-add date? It's actually a very useful little button up here in the keypad. This is called the peel button. And what this does is removes the function but leaves its argument in place. So I'll click that. Round gets kicked out, but I keep date there just as I wanted. So now I want to change the scope of the rounding function to be the whole ratio here. And I can do that in a number of ways. I could simply click at the outermost level. Or, starting back at date, you can't see me doing this, but I'm actually just clicking up on my keyboard, just the up key. And that kind of jumps up one level in the hierarchy of the scope here. So now I'm at the whole denominator, and I hit up again. Now I'm looking at the whole thing. And so now when I click round, round is going to apply to the ratio as a whole. And I have this decimals argument saying how many decimal places do you want to round to? And I'll say 3. I'll click apply, and now you can see over on the right, we've rounded off to 3 decimal places. So this is our function. We're good to go. And you can see as we went along, I was clicking apply and checking out what was happening in the data table to make sure I was on the right track, wasn't seeing any mistakes. That's oftentimes enough to kind of check your progress as you're developing your formula. But if you have really complex formulas or really gigantic data tables, these formulas can sometimes take a few seconds to run across your entire data table. That's why we have this preview pane here. The preview pane shows you both the columns that you've used in the formula and then the formula result as well. And in this case, we look at how many rows we've asked to see a preview of. We have just the top 50 rows. And so we can kind of sanity check these. So this is nice. Using the preview, if you have complex formulas that take a while to run, you can test them out in the preview pane without hitting apply and waiting for them to do the computations on the whole data table. So that's the formula editor in a nutshell. We have our formula box, where the blue highlighting specifies the scope. We can type into that box or point and click. If we want to go the point and click route, we add both columns and functions, as well as operations as we see fit. Then we either apply or look at the preview to make sure we're on the right track, and when we're done, we click OK and we have our formula.
When you were doing the calorie formulas, are you summing across rows?
Yeah, so that's what call sum does here. So what this does is take the sum of all the calorie values across the rows in the data table. And in this case, it does it separately by date and now meal. So that is what's happening. This calories here just refers kind of at the individual row level. So take whatever the current row's calorie value is, then divide it by that sum of calories across rows.
Is there a way JMP can add trailing zeros?
So let's try to do that. So we want 0.04 to say 0.040. So if I go to the column info, this is where we're going to find our formatting options. And you can see it's basically taking its best guess as to how many digits to show us. But if I say fixed decimal instead, and say, give me 3 decimal places, and I'll click apply. Now you have 0.040, 0.030, so it's uniform all the way down. Let's move on now to talk about a few specific techniques that I think some folks will find useful. So let's pull up that lipid panel data set that we saw at the outset here. We have a number of column formulas here. One that I would like to draw your attention to is this low HDL. So HDL is what we might call good cholesterol, and so we don't want to drop below a certain value. I have a formula that specifies whether somebody drops below a certain value or not, and just returns a 1 if they are below that value, and a 0 if they're not. So let's look at how we make a formula that can do something simple like this, basically just start categorizing based on the value in another column. So let's pull up a new formula. So we already know we want to do something with HDL, so I'm going to put HDL in right away. And what I want to know is HDL in a given row lower than some value? Let's say 40 to start. This is what's called a comparison, and it's super useful. So here you see a number of different comparison functions. Is A less than B, is A greater than B, and so forth. What these do is do a logical test. It returns a value of 1 if the test is true, and a value of 0 if the test is false. So I can ask, is HDL less than 40, let's say, and I'll click apply, and now you can see we have our 1s and 0s already populating inside the table. So that's comparisons. You can, once again, do less than, greater than, less than or equal to, test for equality, all sorts of things like that. And this is very useful when you need to basically make a logical choice. I need to know if some condition is true or not, and then based on that result, do something else, which we're about to do here. Now, one wrinkle, though, is that we actually have different cutoffs for males versus females. So if I just remind myself here, the cutoff value for males is 40, but for females, it's 50. And so we need to perform this comparison differently depending on whether we're talking about a male or female patient. So for anyone who maybe has done any coding or is even familiar with general concepts, we're talking about something along the lines of an if statement, where we say, if gender is male, then look to see if HDL is lower than 40. If gender is female, we'll then look to see if HDL is lower than 50. This is what's called a conditional. You can find the conditionals right below the comparisons. So I'm going to go ahead and just delete that little bit, and we'll start fresh. Now I'll use, in this case, an if statement, where here we say, if some expression is true, then do this, otherwise do that. And so what I want to do is say, if gender, and now we'll use the equality comparison, equals male, then evaluate whether HDL is less than 40. Now I have otherwise, assuming that if they're not male, they're female, I can say test whether HDL is less than 50. Now I'll go ahead and hit apply. And if you notice, we had a few extra 1s pop up because it looks like we do have a few females that were not less than 40, but they were less than 50. So this is a simple if statement. And you might even have multiple conditions. So, you don't just have gender equals male or female. You might have 4 or 5 that you want to test. You can always add more simply by, again, clicking this nice caret. Oh, that got dropped into the wrong spot, though, but this is how you add more. So that's one way to tackle this conditional problem for male versus female. But I do want to point out, in the formula column we have, that's not actually quite how I did it. This formula is using something called the match function. So the match function you can think of as almost kind of like an if statement where all the conditions are equality. So it says, well, evaluate the gender column, and if you find male, then perform this comparison, and if you find female, perform that comparison. This is a nice clean way of representing basically the same thing as we saw in that if.
So if all of your conditions in an if statement are just testing for equality, this match function is often pretty useful and sometimes actually saves a meaningful amount of time in evaluation when you're talking about large complex formulas or formulas in large data tables. So that's just a bit on conditionals. Again, the whole idea of conditionals is to see whether something is true or not, and then if it's true, you perform some action. And if it's not, then maybe you have another condition that you check and see if that's true, and if so, perform a different action. So that's all we'll say about conditionals for now. Let's take a quick look at another formula column. Here, we pointed this out before, we have triglycerides, and we also have the triglyceride categorization. This one's normal, borderline, or high. In this situation, what we're really doing is we're binning triglycerides. We're taking a continuous variable and we're kind of translating it into a categorical or ordinal variable in this case. Now, one thing that's kind of hiding in one of the menus that I'd like to point you to if you're ever in a situation where you need to bin a continuous variable, if you go to the columns menu and under utilities, you're going to find this nice utility, make a binning formula. So this will generate a formula for you, similarly to how we went to right-click new formula column at the beginning to do that basic subtraction. So you get a formula without having to write it. So let's say I wanted to bin in windows of 25 triglycerides and just put people into groups based on that. I could specify that I want to start at 0. Oops. And go in bins of 25, and now you can see this nice representation of 25 equally sized bins and who's going where. Then I click Make Formula column, and now I have that binning done for me. So everyone's getting assigned to their proper group. So if you're ever trying to bin, that Make Binning Formula utility is really handy. But the bins actually for triglyceride levels, medically speaking, at least when I consulted the Mayo Clinic's website, they're not uniform in width. And so the binning utility only does uniform width bins. So if you look, what I did here was another conditional. In this case, I have 4 conditions. So if triglycerides are less than 50, call it normal. And then if they're in the borderline range between 150 and 200, call it borderline, and so forth. Now, the reason I'm showing you this is to highlight one additional thing. Conditions, sometimes you can apply multiple conditions in a particular piece of your formula. Here, I wanted to know if triglycerides are both greater than or equal to 150 and less than 200, meaning that they fall into that specific borderline range. And so I use this little AND operator to test whether 2 conditions are both true simultaneously. So you can find things like AND or NOT under the conditional menu to kind of string multiple conditions together. You'll notice I did it a little differently down here. In the case where you're just seeing if something falls within a range, you can actually plop it in the middle. So triglycerides, is it greater than or equal to 200 and also less than 500? And I just did it slightly differently up here to highlight the fact that you can string together multiple conditions with and, or, and so forth. So that if you wanted to say, are triglycerides less than 200 and gender equals male, you could have that as your condition. Okay, so let's take a look at another column here and look at another group of useful functions. Here I have the name column, and you see everyone has their first initials followed by a period, followed by their last name. Let's say I wanted to parse this text. I want to pull everyone's last name out. So first, we even have character operations when you're clicking on a character data type column. And I could say grab just the last word, which is going to grab everything after the final white space in that column, which works pretty well. I get Suggs, I get Wilson, I get Quintet. Didn't handle Smith Jr. so well. What I wanted was Smith. So maybe we want to modify this a little bit more. And in doing so, we'll see a little bit more of the character functions that we can use. So you can see we're using the word function. And here we have the description. It's basically just returning the nth word, in this case -1 means just start at the end to give me the first word right after or right before the end, based on some kind of delimiter. By default, it's white space. So let's see if I can get our Smith Jr. Here we go in row 10 right beneath our formula editor here. So what I'd like to do is for that to say Smith, so let's use some more character functions to be able to pull that off. So one of the things that I would like to do is basically return everything after these periods from their initial or their first names, as opposed to after the last space, and that should get me to Smith Jr. Once again, I have the option to specify another argument here, and if I do, you can see it gives me the option for delimiters. So I'll say that the period is actually the delimiter I want. Now I have Smith Jr. Now if I want to maybe get rid of that junior, I can use a pretty nice character function. It's called the munger, one of many of our character functions. In this case, it searches through a string and then finds a certain match of a pattern, and then you can tell it what to do with that pattern, for example, delete it. So I'm going to say that it should, starting at the beginning, look for a string that is space, capital J, R, and add one more argument. What should it do with it? Well, it should replace it with nothing. Okay, now our junior just vanished below. And one last thing to do, you see there are some errant spaces at the beginning of all of these names, so let's just clean that up. So to this whole result from the munger, I just want to trim off the white space, which is our function trim. And I apply that, and we're done. Now with a few embedded character functions, I've grabbed the words that I want following the period. I've gotten rid of that pesky junior, and then I've gotten rid of any white space that I don't want there. So character functions, when you're working with character data, you have all sorts of options for grabbing little bits and pieces out, or, even though we didn't see it, actually stitching multiple pieces of characters together in different ways. So let's move on and look at one more formula now before we answer final questions today. And this is the formula that we saw at the beginning, where we were setting the markers for an individual row based on some calculation. So here, once again, we have the monthly sales data over 12 years, and we have these markers that are specifying for which month our year-over-year sales increased by at least 20%. And if we look at a graph, it kind of looks like this. We can see that there was a nice period early on where we were hitting that 20% growth target a lot, and then more recently it's been a little bit harder as our sales have grown and grown. One additional thing here, you'll notice up at the top I have this thing that says y over y, 1.2. This is how I've specified what the target growth value is, that is a factor of 1.2 or 20%. If I double click this, let's actually make it a little more lenient and say, let's look for 15% growth. Now you can see some of these values here in this row state column have changed. And I can apply that to my data table, and now the graph is automatically updated. So what I'm doing now is actually using a column formula to update how data is supposed to be displayed to me in JMP. Somewhat of a more perhaps non-standard creative use of column formulas. So let's just take a quick look at how we did that. We won't specify the whole formula from scratch. Here we can see it. It starts with this component here, that ratio that determines how much our sales grew by. So we take the current sales, now we divide it by this. So what the lag is doing is looking, in this case, 12 rows previously and finding the value in the sales column of that row. That's one of a number of different row functions. So lag looking backwards in the table, row just returning the actual row number in the table. The difference can just do a subtraction between your current value and a value at some other point in the table. So these row functions are quite nice if you need to incorporate some value that occurs either previously in your table or further down in the table. And then I take this resulting ratio, and I compare it to that year-over-year variable. Now you can see year-over-year is appearing in italics there, which is how you know that that's a variable that I've specified somewhere and I have control over. I specified that variable by just going to the red triangle in my table and specifying a new table variable, which means that now whenever I change that variable here in my table, it ripples through to this function, or this formula, excuse me, and any other formula that incorporates it. Now there are other ways to create variables. They don't have to be table variables. You'll notice right here we have our table variable dropdown, and it's this last little bit of the formula editor that we haven't really talked about. You can also specify local variables, that is a variable that is local to the specific formula but not shared across the rest of the table. We also have the availability of constants if you just need to use pi or e or something like that. Then finally, parameters are variables that are actual model parameters. So in something like, say, the nonlinear platform, you need to feed it a column formula that actually specifies a model, and it needs to know which variables in your column formula correspond to the model parameters. This is how you do that, by specifying parameter variables. So finally then, we just see this bit here, the marker state, as the last bit of the formula that actually specifies which row marker we should use. And so what this does is it takes a value between 0 and, I can't remember the exact maximum, the number of different row markers in JMP. And so how I specify the one I want was simply take the result of this comparison, which is either 1 or 0. And so if it's 0, it returns 0 and gives us just this little point. And if it's 1, that gets multiplied by 4 and returns a diamond. But if I, let's say, change it to, I think it's 11, will give us an asterisk, and so forth. So an interesting little way to try to get creative and almost piece together in a slightly non-standard way interesting behavior. And I think that's a good stopping point, and just to kind of call out the main way in which formulas can be useful is that all these formulas that we've looked at so far, they're often big and complex and do interesting things, but they're built out of a bunch of simple little building blocks. And none of the individual building blocks are really that complicated or that hard to understand. It's more just making sure that you find the right ones with these functions and whatnot. But once you have the right building blocks combined in the right way, you can create formulas that will do almost anything. I mean, you can create any kind of new variable you could possibly imagine, you could possibly need, all by just piecing things together. And the formula editor is a tool that JMP provides to try to make that as easy as possible. So you don't have to know JSL, you don't have to know how to code, you just point and click your way there.
Can you create formulas across tables and nest these tables within the same JMP file, like with the worksheets in Excel?
Yeah, so JMP tables themselves each exist independently, unlike worksheets bundled into a file. You can bundle multiple tables together in a JMP project, so really that gives you just a single window interface while still maintaining the separate tables. What you'd really want to do is join or virtual join the tables together if you want to have dependencies among the formulas or formulas in one table drawing on the columns in another table.
Can you please comment on how to perform derivative and integration operations in the formula?
Well, I will point out that under the red triangle here in the formula editor, we do have the option to take the derivative of a function. As far as integration, that at least is not available here. That's something I would need to look into to see if maybe there's a JSL solution. But I know that you can specify the derivative just under the red triangle.
Could you add a condition in match, for example, which will evaluate if it doesn't match any of...
Right, so you have match and you want to match some expression, and then you can say that it should have some value and then another clause. If you add another one, the first thing it does is just gives an else to say, okay, if none of those matches apply, here's what you should do.
Can you convert formulas into Python code as you can, like when you save out formulas to Python from prediction formulas?
Sure, let's see. I believe the answer to that is yes if you have JMP Pro. So here's a basic formula. If I right-click, one of the things that I can do is publish it to Formula Depot. Again, that's in JMP Pro. I publish it to Formula Depot, and then for this particular formula, I can go ahead and say generate Python code. I hope that you've seen something you can use today, and that you'll go off and try to make some new formulas on your own. And also, once again, thank you to everyone who stuck with us through the technical issues we were having. I appreciate your patience.